I would like to invite Dr. Megan Jason from the IMO, our first presenter today, to refresh our knowledge on the Ballast Water Management Convention. Dr. Jensen, you have the floor.
Thank you, Wen-Tao. One moment while I pull up my slides, please. Okay, Wen-Tao, can you please verify that my slides are showing?
Yes, it's perfect.
Wonderful. Thank you. All right, and thank you for the floor. I'm going to give a brief introduction to the Ballast Water Management Convention, some of the more critical aspects of it. Obviously, in a short presentation, we don't have time to cover all of the aspects that we would during a full multi-day workshop, but we will hit the more important points this morning, and then spend some time talking about the exemptions process as well, because we know that is of interest to many participants in the region. For the presentation today, I'll give an overview of the convention, and then we'll move on to the exemptions. We'll do a quick introduction of the exemptions. We'll cover the principles of risk assessment that need to be conducted when granting exemptions, and then we'll do a brief introduction to the same risk area concept. So the Ballast Water Management Convention was developed in order to fight the spread of non-native species carried by ships in their ballast water. Ballast water is, of course, necessary for safe shipping. Ships will uptake ballast water at a source port, typically when their cargo holds are low or empty, in order to achieve safe drafts, safe navigation, and safe stability. This ballast water will then be discharged at a destination port, but all of the organisms that live in that water then are discharged in a port and contribute to the spread of non-native species or aquatic invasive species. This is a problem because shipping breaks the natural barriers for species dispersal, and as we'll hear much more about later today, there are many regions of the world that have been very highly invaded, which causes untold economic and environmental damage. The Ballast Water Management Convention was developed in order to develop provisions for managing ballast water in order to reduce the risk of transferring invasive aquatic species. The convention was adopted in 2004 and entered into force in September of 2017. The current ratification status is 85 states, representing just over 91% of the world's gross tonnage. There are two primary options for meeting the Ballast Water Management Convention. These are known as the D1 and the D2 standards. The D1 standard is an exchange standard. Ballast water for ships that must meet the D1 standard must conduct exchange of their ballast water in water that is preferably 200 nautical miles from land, but no less than 50 nautical miles from land, in water that's at least 200 meters deep. If that's not possible, the port state might designate a ballast water exchange area. The D1 standard is an interim standard for ships to meet this standard until such time as they're required to meet the D2 standard. The D2 standard is a ballast water discharge standard or a performance standard. It specifies the number of viable organisms per unit volume of ballast water that can be discharged. Once a ship passes its D2 date, this is the permanent standard that ship must meet. I want to quickly mention that there are alternative options. We won't be focusing on these today. These are in practice quite rare and include things like port reception facilities. But the vast majority of ships in the vast majority of circumstances must meet the D1 or D2 standards. Now, to comply with Regulation D1 and conduct ballast water exchange, a ship must exchange at least 95% of the volume of the ballast water in its tanks. This is generally considered, or it's specified that this must, for certain types of exchange, such as flow-through or dilution, this is 3 times the volume of each tank must be flushed through to be considered equivalent to 95% of the tank's volume. The ship should not be required to deviate from its intended voyage or to delay the voyage in order to comply with the distance and depth requirements. If the distance and depth requirements of that 200 nautical miles preferred, 50 nautical miles minimum, and 200 meters depth, there are many regions of the world that those cannot be met. In these cases, the port state may designate areas where a ship can conduct ballast water exchange. Ballast water exchange might not take place if the master decides it's unsafe. Ships were not designed to conduct ballast water exchange, and in some conditions, this can be a risky operation. So it's possible that the master says it's unsafe, in which case the ship might not conduct ballast water exchange. Regulation D2, or the D2 standard, is the discharge or performance standard. The D2 standard specifies that ballast water discharge must contain fewer than a certain quantity of viable organisms per volume unit, as well as certain indicator microbes that must not exceed specified concentrations. The convention does not specify how ships must comply with the D2 standard. In practice, the vast majority of ships will choose to comply by installing ballast water management systems. All of these systems and compliance technologies must be approved in order to ensure they meet the relevant IMO standards, have minimal adverse environmental impacts, and are safe and suitable to be used on board ships. The 2016 guidelines G8 guidelines have been made mandatory as the Ballast Water Management System Code, the BWMS code. And these cover, among other things, testing and performance specifications for ballast water management systems, as well as the type approval process. Further, any ballast water management system that uses chemicals or what the convention terms active substances requires additional approval by the Marine Environment Protection Committee in accordance with Procedure G9. These systems must submit proposals that are evaluated by the GAZAMP Ballast Water Working Group in order to ensure that these systems using active substances are safe for human health, the ship, and the environment. So the G8 guidelines, now the BWMS code, covers the efficacy of the system. G9 ensures the safety of the system. Moving on to the obligations of flag states to the convention, the primary responsibility of flag states is to ensure that vessels flying the flag are in compliance with the convention. And there's several aspects of this. The flag state must survey ships and deliver certificates. The flag state is responsible for enacting domestic legislation, including sanctions. It's responsible for taking action when a violation by a ship flying its flag is reported. The flag state must recruit qualified flag state officers and make sure they are trained, as well as evaluate the performance of its own measures. Port and coastal states, under the provisions of the convention, have many rights and obligations as well. The primary goal is to enforce the convention in order to protect their own waters. Port states have the right to intervene on board a foreign flagged ship in their port or waters. They have the right to enact domestic legislation. They have the right to carry out port state control inspections. They must provide reception facilities for sediments if so required by the provisions of the convention, and must take action when a violation is detected. As I mentioned, this is a very, very brief overview of the convention. There are a number of other aspects that we won't be able to cover today that I hope to deliver in person in the future. But these include port state control, including both inspections and sampling, the survey and certification process, the records that must be kept, including the ballast water management plan and ballast water record book, Regulation B3, which covers the timeline of when a ship meets its D2 compliance date, additional measures that might be taken by a state, ballast water uptake warnings, and the experience building phase of the convention. Moving on now, we will cover a brief introduction to the exemptions process. Section A of the annex to the convention covers exceptions and exemptions in regulations A3 and A4. A3 covers exceptions. These are cases where ships are not required to manage their ballast water, and these are cases where the discharge of unmanaged ballast water is necessary for ensuring the safety of the ship or life safety, if it is accidental due to damage or to the ship or its equipment, or in cases to avoid or minimize a pollution incident. A ship is also accepted if the ballast water is loaded and discharged in the same area or in the high seas. Exemptions in Regulation A4 can be granted by administrations to ships operating between specified ports or locations. In this case, a risk assessment in accordance with the G7 guidelines is required, and any adjacent states that might be affected must also be consulted. Exemptions are typically meant to be granted to a ship always on the same route, for example, a ferry. These are meant for cases that cover a relatively short distance within the same biogeographical region in order to minimize the risk of transferring invasive species. In order to be granted an exemption, a ship owner must request authorization to the port and coastal states and must demonstrate an acceptable risk. But of course, there is no such thing as zero risk. Exemptions must meet certain conditions. For a ship to be granted an exemption, must operate between specified ports or locations. Consultations with other states that might be affected are required. No ballast water can be mixed with water from other locations. A risk assessment must be performed. The exemption is granted for a maximum period of 5 years. It must be communicated to the IMO. The exemption must be recorded in the ballast water record book. And of course, the provisions under guidelines G7 must be met. For ship owners, there are many implications of exemptions. The advantages are clear. There's no ballast water management that's required. They don't have to conduct exchange, install a ballast water management system, etc. So there are no associated maintenance or operating expenses. The crew is not required to be trained on specific equipment or procedures. There's no risk of violating the convention because it's exempt, and there's no administrative burden. However, there are also a few drawbacks. There is the cost of the risk assessment, though typically this would be lower than the cost of management equipment. The exemption must be reviewed and can present restrictions for the ship. The ship is not exempt from some key elements of the convention, such as having a ballast water management plan and record book. But the primary drawback might be a restriction in the ship's navigation. There's no flexibility, as it cannot operate outside of that area, where it is exempt then if it has no way of meeting the convention's provisions elsewhere. And this can affect the resale value of the ship. For the Port Authority, The responsibilities are to either conduct or require the risk assessment for the exemption, to provide acceptable procedures and guidelines, to evaluate the risk assessment, and collect evidence of compliance. It is the ship owner's responsibility to contact the parties, to ascertain the risk assessment procedures, to follow the guidelines provided by the parties and IMO, to provide evidence that no ballast water is being mixed, and to provide voyage analysis in order to meet the risk assessment and show that it is complying with the terms of the exemption. I want to stress for the risk assessment that there's a great deal of scientific data collection and analysis required. Risk assessments require in-depth analysis of each location. This includes conducting port biological baseline surveys and studies and mobilizing on-site research to really understand what organisms are present in both locations and the environmental conditions in order to accurately judge the risk of transferring organisms between those two locations. This requires a systematic analysis of data and as well as ongoing verification. We'll move on now to the principles of conducting risk assessment for exemptions. Regulation A4 and the G7 guidelines lay out a number of principles. These include determining the best methods for conducting a robust risk assessment, collecting data, making informed decisions, which involves ascertaining what is an acceptable versus an unacceptable risk, as well as whether to accept the exemption or not. 3 risk assessment methods are presented, and I want to note that these can be used individually or in any combination. The first, and we will talk about these briefly, is the environmental matching risk assessment, a species biogeographical risk assessment, and a species-specific risk assessment. The principles laid out in the G7 guidelines are effectiveness, transparency, consistency, comprehensiveness, risk management, precautionary, science-based, and continuous improvement. All of these principles are meant to inform the risk analysis in order to determine accurately whether a given situation will present a high or low risk situation. Again, the ultimate goal here is to protect the environment and to minimize the risk of invasive species transfer. I mentioned the 3 risk assessment methods that are laid out. The first is the environmental matching risk assessment. This risk assessment assesses the degree of similarity between locations, which can provide an indication of the likelihood of survival for any species transferred between those 2 places. The principle here is that nearby ports with a high similarity have a common ground for invasions. The main steps here are to document the conditions of the water, temperature, salinity, other environmental or abiotic conditions, to compare them, and to consider any variations either seasonally or geographically. The second risk assessment method is the species biogeographical risk assessment. The principle here is that overlapping species in the donor and recipient ports and regions are a direct indication that environmental conditions are sufficiently similar to allow a shared flora and fauna. This means that if in Port A, many or all of the same organisms are living there, as do in Port B, there's a limited risk, as those organisms are already shared. They're not likely to be invasive. And this is considered the same biogeographical region. In order to conduct this kind of risk assessment, a record of invasion in the region is necessary, as well as a record of both native and non-native species that have spread, including their histories and harmful potentials, and comparing and verifying overlapping species. The third method is a species-specific risk assessment. And this looks at individual species, information on their life histories, and physiological tolerance to estimate its potential to survive or complete its life cycle in a recipient environment. This will include a list of target species, their known physiological tolerances, such as temperature and salinity, as well as uncertainties, as many organisms are able to quickly adapt to new habitats. This type of risk assessment assesses the risk of the invasion of a specific species based on its habitat and likelihood of survival in the recipient port. Finally, I'm going to spend a couple minutes talking about the same risk area, or SRA concept. The same risk area is an agreed geographical area that's based on a completion of a risk assessment carried out in line with the guidelines, the G7 guidelines. The same risk area concept builds on these risk assessments and consultations between states in accordance with the provisions of Regulations A4 and Guidelines G7. This approach facilitates granting of exemptions in specific areas, and it's expected to be useful, for example, for short sea shipping. It was agreed by MEPC 70 a few years ago that administrations may grant exemptions in accordance with Regulation A4 based on the same risk area concept, subject to consultation and agreement between states that might be affected by such exemptions. In effect, the same risk area is a geographical region that ships operating exclusively in would have an exemption from ballast water management. In short, the principle behind the same risk area concept is that the risks generated by shipping are not considered high compared to the natural dispersal of species, as they are considered within the same biogeographical area. Therefore, ships operating exclusively within this area may be granted exemptions. In order to ascertain and grant these exemptions, the natural dispersal of organisms in this area must be evaluated. This includes assessing the probability of dispersal using techniques such as hydrodynamic modeling and biological features of target species. The ship still has to apply for this exemption, and its exemption is to be recorded in the ballast water management plan. The exemption only applies if the ship is operating within the same risk area without mixing any water from outside the area. And a risk assessment is, of course, required and must also include a species-specific risk assessment in order to define the same risk area. I've covered a lot of material in the last few minutes, so just to conclude the exemptions material, exemptions require a step-by-step process with a lot of analysis and data collection behind it. The G7 guidelines present a basic methodology for carrying out the risk assessments. Exemptions are for a limited period of time and limited geographical areas and require a periodic review. But there is the same risk area in order to undertake a regional approach to exemptions. That's the end of my slides, and during the Q&A session a little bit later this morning, I will be happy to take any questions. Thank you.